Hi everybody. I'm going to check in about number 8 from the Physics C textbook, and then I believe it's number 13 from the Physics 1 textbook. It's a conceptual question. Actually, let me check. There were a couple that were really similar in the Physics 1. 13. No, it's number 14 in the Physics 1 textbook. Okay, so what this one says is answer the following questions for projectile motion on level ground, assuming negligible air resistance with an initial angle being neither 0 nor 90, so it's not horizontal or vertical. Okay, so our situation is we're going to launch a projectile at some angle, and I'm just going to use like a 45 looking angle. But we know it's not straight up and we know it's not straight out. Other than that, they're all going to pretty much behave the same, right, in this middle area. So it's going to go up, it's going to reach its top point, and then it's going to accelerate back down. All right, so this is kind of what our projectile is going to do. And so it says first, is the acceleration ever 0? Well, as this projectile is going up, it's being pulled down by gravity, right? With gravity pulling with an acceleration of 9.8 meters per second squared. As it comes back down, gravity continues, the acceleration due to gravity continues to be 9.8 meters per second squared. So the entire time, the acceleration due to gravity is going to be 9.8 meters per second squared. So is it ever going to be, what did it say? Is it ever 0? No, it's not ever going to be 0. It's always going to be 9.8 meters per second squared. Okay, now is the acceleration ever in the same direction as a component of the velocity? Okay, so here the acceleration, we know that the acceleration is always pulling down, right? In our velocity vectors, we start out big and then they get smaller and smaller. We'll just look at the vertical direction of it. Then it becomes nothing and then it starts to go down, 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 getting bigger and bigger as we go back down. Yeah, so that's kind of what those vectors look like. So it's asking us, where did it go? Is the acceleration ever in the same direction as a component of the velocity? So on our way down on the descent, the velocity and acceleration vectors are in the same direction. Okay, and then it asks us for part C. So this is A, this is B. For part C, is the acceleration ever opposite in direction to a component of the velocity? So are they ever opposite in direction? Well, yeah, they are right here on the ascent or on the way up. Acceleration and velocity are in opposite directions. Okay, so that is part C. So that is number 8 for Physics C and number 14 right, for Physics 1. Hopefully this was helpful, and if you still have questions, let me know. Thanks.